All right. So today I would like to talk a bit about how we could potentially rethink how CI works compared to the current CI situation that we have, with a particular focus on monorepos and potentially large monorepos. So how we could optimize that. So before we go ahead, my name is Juri Strumpflohner. I've been using monorepos for probably 6 years already. Since about 4 years, I'm also a core team member of NX, which is a monorepo management tool. And so I'm also a Google Developer Expert in web technologies and Angular, and also an instructor on Egghead, where I publish courses on web development and developer tools. So when we go into the direction of a monorepo, it doesn't come for free, right? So there's some considerations that need to play in. One big one is obviously the local developer experience. So how do we structure a project in a monorepo? How do we make sure that we have a consistency in how these projects are being set up, that which version they use, like how are they configured, such that we can also have some sort of team mobility between projects potentially, and it will also help us obviously maintain. Automation and rules around like those projects is also a very important part, especially looking at maintenance and the longevity of such a monorepo. And also things like features like task pipelines, being able to run things in parallel, because clearly in a monorepo, we don't run just one project anymore, but potentially a series of projects where there are also dependencies. And so we need to be able to kind of build dependent projects first before we actually run our project. And those are things that we don't want to do manually, but rather want to have like tooling support. But today I would like to specifically focus on kind of like the elephant in the room whenever we talk about monorepos, which often is the like kind of like not being paid attention to immediately, which is kind of like a mistake, which is CI. Because clearly, there is some, like the current CI situation is basically not optimized for monorepos because it is very machine oriented. So we need to kind of focus on exactly the instructions that we want to process. Like we need to actually have a very instructional kind of approach. It is very low level in that sense as well. It requires a lot of maintenance because we no more, as I mentioned, run just one project and that's it. We run a series of projects, we run multiple projects. And so we need to have strategies of like tuning the CI in order to make sure even as our monorepo structure changes, as more projects come into the monorepo, that it still works. It is also, I would say, a bit removed from what developers want, because like as a developer, I would want to have a more high-level way of defining my CI structure, my CI my CI pipeline, in the sense of saying, hey, I want to run all these projects that got touched, for instance, that PR, rather than having to fine-tune every single aspect of that project. And as I said before, they don't really work for monorepo, so they're designed much more general purpose and more oriented to single project workspaces in general. So today I would like to dive into some of these aspects, specifically looking at speed and throughput, because that is one major thing that we need to pay attention to, because otherwise our monorepo would be a problem. Because if we have good collaboration going on locally within teams, but our pipeline takes over an hour for each PR, that's going to be a problem. And also looking at the complexity and maintainability aspect, because clearly, as I mentioned before, we don't want to have to do all the running in parallel, spinning up machines manually, things like that. So I want to look a bit into how a potentially different approach could help with that complexity and maintainability. So this is actually pretty obvious, right? So if we have more projects in a single repository, the CI time will sum up, because we need to now not just one project that needs to be built and tested and linted and running end-to-end tests for it. But now we have like 5, 10, 100, which is easily a real number. Like I've been working with clients which have like over 600 projects in a single monorepo. And so we're talking potentially about these sizes. And so as I mentioned before, if we don't pay attention to the CI aspect of a monorepo, we might run into congestion basically. And so we get results like these, which are basically not manageable, because developers will find workarounds. Like they need to ship, like they have like a sprint going on where they need to deliver certain features. And if each PR run takes over an hour, they will start collecting PRs into, like collecting features into one PR. And then we have those gigantic 200 plus file changes, which are impossible to review. And therefore the quality obviously suffers quite a lot on that. So what we want to have is something like that, obviously. Like we want to keep that as low as possible and keep it almost flat, ideally, and not something that kind of grows up exponentially with more and more products that we have on our monorepo. So how do we do that? One of the fundamental things that every monorepo has somehow implicitly behind the scenes is a graph. So projects in a monorepo reference each other. So that might be either through some dependency resolution mechanism, depending on the tool you're using, but it could also just be the reference in the package JSON where you reference the source of that other package you depend on. So there's a graph that is being built in a monorepo, which reflects the dependencies. And so we can leverage that graph information, saying, for instance, like if you run the build for this project or you serve this project, if this is an application, for instance, then we can look at the configuration of your monorepo and say, potentially we might need to have to build also its dependent children first, because that might be a dependency, an input for that other project to actually run, because those need to be pre-built first. And so those are things that we can specify, usually for which we need to have a tool in order to not have to manually configure that and change it over time as the structure changes. And so we don't clearly want to have things like this, but we want to have a parallelized run as much as possible to save time. And again, as you can see here, account for these dependencies potentially that are between projects, where this might depend on the output of the previous one, as we have just seen. And therefore, we need to have a mechanism that is intelligent enough that when it does such a parallelization, it also keeps those things into account, which usually is being referred to as like a task pipeline, where we can, in a quite easily way, define how these dependencies look like, also leveraging a graph behind the scenes. And so this is something, for instance, that we at NX do, because like that is something of the basis that you need to have in a monorepo. Another thing is also being able to just run affected nodes in CI, but also locally. So with affected nodes, I mean, basically, if you change a project here in the middle, we can infer that potentially we need to run the testing and building and end-to-end tests also of these upstream projects, because they depend on that project that we changed. And so potentially we may need to rerun, because otherwise maybe we introduce some breaking change and they don't build anymore, or the tests pass anymore now. So we need to kind of adjust that. And so with such a mechanism, which we call affected, because it's literally a command that you can run, nx affected, and then you give it the targets for which you want to calculate those affected nodes. That gives us the ability to just now create like or run a subset of the entire amount of projects that we might have in a monorepo on our CI system. And so you can already see like these are some considerations that should play into our CI configuration to make sure that that curve that we have seen before keeps as low as possible. Overall, though, what we've discovered, like working a lot with like companies and large monorepos, is there are those three aspects, like these that we have just seen, like parallelization and affected. Those are kind of prerequisites, but those that make a real difference are these three roughly. Now, these are some marketing terms as well, so don't be distracted by those. But basically, those are those three features, while NX Workflows is something that's coming more down the road. So we're focusing on NX Replay here and NX Agents. So what NX Replay is basically a computation cache. Now, we call it replay. I said, like, it's kind of like a marketing term if you want, but it's basically a distributed remote caching that you can add to your project. And replay, therefore, because it literally replays computation. So meaning if you have a project, NX will compute a hash key out of various sources. That is obviously the source code itself, environment variables, things like runtime variables that you might also give into that key. And then it computes a key and stores the output alongside with that key. And so if we run another computation again, and we have a matching key, we will restore and basically replay both the terminal output as well as artifacts, because clearly some of the commands, some of the tasks might produce compiled JavaScript files or CSS files or some other sort of processing that you might be doing. And so those are being replayed as well. And so that's why it's called NX Replay. And this is highly valuable, because if we take a look back again at our affected situation where we changed the node in the middle, we push it up as a PR to our repo. Our pipeline runs through. It identifies these are the affected nodes. But what happens during the processing, now one of the upstream project actually fails the tests, because as we said before, we changed something, the tests don't pass anymore. We need to fix it. So what we do again, kind of download that PR, like we fix it, we push it up again. Now, if we just had affected, we would need to rerun all these nodes again. But if you look at it, there's no point actually to compute some of them, because they literally didn't change. So that sub part of the now smaller graph, the affected graph, is not affected because it will be pulled out of the cache, because we have a matching cache key that we can just replay now. And we just remain with some other two projects that are here, as you can see here with the hourglass, which need to be recomputed. And so now you can see we can constrain that path even more and make that even faster. And obviously, as more team members work on our projects, we'll get more cache hits naturally out of it. And so our PRs will potentially get faster. Now, another point though is like, what happens if those lower level, more, let's say, worst case scenarios happen where we change a node that is simply has a lot of dependent projects because it is a central part. It could be, for instance, the design system, which is like a common one, but also some authentication logic libraries or things like that, where a lot of other projects depend on it. And so if we change that, we will hit very often a worst case scenario where the affected kind of projects are almost the entire graph because like the project depends on that. And so what is being done there usually is to distribute. And so rather than just basically parallelizing things as much as possible within the same machine, what we're trying to do is distribute them across different machines. And so here you can see, like here we distribute them across machine 1, machine 2, machine 3. What you can see here though is it is a very uniform kind of distribution, right? And so that's usually what happens if you manually set it up, because distribution is hard because like you need to code it somehow. And so a very straightforward, potentially naive way of doing it is you just cut it by the different tasks that you have and then basically run it through the different machines. And so here you can see like the different running times might lead potentially to a low efficiency because some tasks might take a long time and therefore the entire run takes longer, but other machines are already idle because their task, like let's say the linting, was quicker and they're already done. There's also the number of machines is kind of static. So usually you define the number of machines and then basically that is the number that is kind of like nailed or fixed there. And you need to kind of tune it over time as your monorepo structure obviously gets bigger and grows. And there's also complexity potentially in spinning up those machines, depending on your project or CI provider that you're using. And so very often what I see is like scripts that are being done on CI. For instance, NX has a programmatic API, so you could compute those affected nodes programmatically and then kind of try to shuffle them in some intelligent form where you kind of distribute them across different machines and dynamically even generate pipelines. So this is an example, for instance, for GitLab, which allows you to dynamically spin up nodes and therefore have some sort of distribution going on. But it's a very static thing, as you can see, because it's kind of like hard-coded into your code and cannot really adapt to a changing monorepo structure. So this needs a lot of maintenance. And so having seen some of these difficulties that teams face in creating these custom scripts, we've been looking into what we call NX agents, basically to help with that distribution, specifically to set up the machines, but also with the dynamism of the distribution itself, such that you don't need to tune it continuously as your monorepo structure grows, but the distribution would happen dynamically based on the number of tasks that's being run, but also based on the kind of running time of these tasks based on historical data, basically. And so the NX agent tries obviously to leverage the project graph because it has access to the NX graph behind the scenes. And so it knows how the projects are being structured and what dependencies there are, which is a major important point when you distribute, such as to distribute them in a way that is efficient. And you describe what you want to run. So you don't describe how you want to run them, but you rather just say, I want to run like the affected test build and linting and end-to-end tests in a certain way, but you don't define how they're being distributed. And one big part that comes with the first version of the NX agents is like the whole dynamic scaling aspect. So spinning up more machines depending on the PR, but also fine-grained distribution and also flaky task rerunning. Now, we specifically focused on tests and end-to-end tests right now, but in theory, we can detect flaky tasks and automatically rerun them on CI. So let's have a look. How does it describe what your run look like? Well, all you need to do basically for the distribution to activate is basically this line. So specifically the dash distributes on, where you give the information, I want to distribute my tasks that are being run right after on 15 machines, in this case of denoted Linux Medium Plus JS. And so those are the nomination of names of machines based with a certain characteristics, which you obviously can define based on the needs that you have. It's kind of like a Docker setup almost. And then you run the actual commands. And so here you can see how you describe what to run and not how. So we just simply say, enable distribution, so many machines, these are the commands. That's it, right? And so what happens is like the project graph information is being leveraged, and that is available on CI. You trigger that script as we have just seen, where you run the affected build with the distribution on. That is being passed to a coordinator machine, which is on the NX Cloud infrastructure, which then takes those tasks and tries to split them up into more fine-grained tasks, which are then distributed across the number of machines that you specified. And the interesting part is that if we see that we need more machines, we can add some or even dynamically expand them, but we don't have to change the actual configuration underneath. And so that helps greatly with the configuration overhead or complexity that we mentioned initially, because now these can just balance out automatically. It's just as if the coordinator now has 4 machines, while the whole distribution can now happen in a different approach and a different, potentially more efficient approach. And as I said, these are hosted on the NX Cloud infrastructure, which can also be on-prem. So if you need to have it on-prem, obviously that works as well. But the core part here is like on your CI, you just define the distribution and kick that off. But on the cloud part, basically the whole infrastructure is then being managed. So how does fine-grained distribution look like? Well, basically, one of the big concerns that we often have is that machine in the middle. So that end-to-end test, the red block that you can see. Because like very often what happens is you have those gigantic Playwright or Cypress tests that run for a given application. And they're really hard to split up because it's just a one big block. And they occupy an entire machine, which can then lead to the whole distribution not being efficient. And so we looked into it with a feature that is landing in NX 18, which allows us basically to split dynamically, basically create tasks for targets, basically for an end-to-end test at the file level. Because Cypress as well as Playwright allow you to run single files with a filter. And so NX can do that automatically, with the result then that we can kind of split these up into the individual file level test runs. And so we can group them in some intelligent way. And now we have much more fine-grained pieces that we can distribute. And so we can balance out the machines much better and therefore lead to much better results. So if you look at a concrete example, here's a workspace, an NX workspace with a couple of Next.js applications with Cypress end-to-end tests. And I just have a couple of tests here, which are very similar, which have some sleeping in here, some waiting to artificially boost or bump up their running time. I also have NX console installed. And what that allows me to give is to see what targets are being defined for such a project. And so if I go here and click on that link here, we can see we have an end-to-end test, but NX automatically detects that this is a Cypress end-to-end test. And so per file, it gives us basically a target that is being dynamically created. And so that means we can now not just run the entire end-to-end test, but we can run each single file as well automatically. And this is what NX will do at the CI level. So if I make here a couple of changes on the crew pages here, let's say we say here, hi there, 3, and let's also do the same here for the flight simulator, just to have a couple of changes that are going on here, so our tests will change. And now if I add that and push that up on CI again, so once it's being pushed up, what will happen is CI will run my script here. And if you look at the script, this has been auto-generated by NX. We have enabled a distribution here with the distribute on for now 5 Linux machines. So this is a static number of machines I'm running the distribution on. And what I want to run is, first of all the tests and builds, and then the end-to-end -CI, which are the fine-grained distributed CI pieces that I can run on CI. Now here I have just the run many, so I want to run all of them. So if I go to my repository here, you can see here the run that is being started. So right now the end-to-end test run. And so if I go to the CI page for NX Cloud, we see there's an in-progress pipeline execution, which now you can see already distributes those end-to-end tests across these different agents. So you can see now one test per agent is being run And this depends highly on how many agents we have at disposal and how the distribution is happening here. You can also see like some things have already been completed, and here you can see how they are being stacked up and how that distribution is happening. But the important part here is like with a simple flag, we distribute now all of these tasks across these different available machines. And we have seen some examples there where we came from like 90 minutes of an end-to-end run in like CI down to 10 minutes just with such a more fine-grained distribution by NX agents. Similarly, we can do Fakeness Detection because we can understand based on the cache that if there are some flaky tasks that have, like basically if you have a test run on CI that has run before with a certain hash key, and we find that hash key again down the road at some point, but it now leads to a different result, we know we can detect these and know for certain that these are flaky. And so we can basically spin them up and move them to a different machine just to make sure we have a clean setup, a clean startup phase, and rerun them again. So here you can see, for instance, there was an attempt on the left-hand side where one test run failed, and we knew that was potentially a flaky test. And so automatically a retry has started, and the second one then turned out to run properly through, and that was marked. And so we can first of all surface that information, but as you can see also we can kind of retry automatically. And so basically the whole pipeline again succeeds rather than goes and fails. As you can see here, that run happening. Another part here is also the dynamic scaling, because clearly some of the PRs might look very different. So you have some PRs which are running all those end-to-end tests because some of the parts were affected where we need to run them. Some like PR2 or PR4 are super quick because we just changed one project. We just need to run a test for it. That's it. And so if we have a static number of machines, that might be suboptimal because some of them might just run idle, or the distribution will just end up being one task per machine, which is really inefficient also cost-wise. And so we also allow to not just give the machines, but actually give a change set, a dynamic change set file, where you can define like machines for small change sets, medium and large. So right now we give this type of distribution, and we will automatically then, based on the affected nodes compared to the entire set of nodes in a project graph, distribute them accordingly and just like launch 4, 8 or 12 machines. But in the future, we can actually start doing much more fine-grained approach where you can potentially define a percentage of the graph that will classify for you like a small, medium or large. So give you even more flexibility there. So this has been just some of the things that I wanted to give you a glimpse into how we want to start rethinking how CI works, especially for monorepos. What we really try to do at NX is kind of give you the end-to-end experience, right? So we have the smart monorepo side on the local developer experience where we come with like tools that help you structure monorepos, kind of facilities for allowing you to easily automate such monorepos. But we also want to make sure that you're not kind of left alone on CI with like complex setups and complex scripts on CI to make sure you succeed there as well. Because if CI doesn't work, you can have the best local developer experience, but like that will simply be a problem and you will move away again from monorepos just because of that reason. And so that's kind of what we try to fill in. We do that with NX Cloud, which is our product there. And you can connect us with NX Connect, and that will kind of walk you through the setup of the whole distribution. And again, the major important part here is the simplicity of defining such a distribution with just a single flag. And so that single flag gives you the distribution across these machines, the potential dynamic scaling of these machines depending on the size of the PR, so you save costs actually, and you don't run machines unnecessarily. The task splitting, which is kind of a combination of NX being able to dynamically split those, but then also then help on the CI side where NX agents can pick those up, those more fine-grained tasks, and distribute them much more efficient way. And finally, also the flakiness detection of tasks. So that can be end-to-end tasks, but potentially can be any other tasks as well that could be flaky. And definitely check out our YouTube channel. So a lot of those in that info and more deeper dives we publish there. And otherwise, get in touch, reach out. If you have questions, my DMs are open also on X. Or we have a Discord, a community Discord, which is pretty active. Or obviously you can go to nx.dev/docs where we have all the details. Thanks.